Okay, good morning. Welcome. Today we're going to discuss on galvanic cells or voltaic cells, okay? So by the beginning of this unit, we've said that there are two types of electrochemical cells, being the electrolytic cells and galvanic cells, okay? So what are electrolytic cells? Electrolytic cells. Electrolytic cells are cells that convert electrical energy to chemical energy, or it's you can see it from the name. It's electrolysis, using electricity to bring about a chemical change, okay, or to split an ionic compound into its respective ions. This is called electrolytic cell. And then the other type of cell is known as the galvanic cell or voltaic cell. So what are these cells? Can you give me examples of galvanic cells? Batteries, right? Batteries use spontaneous chemical reactions to generate electricity. Good. So today we're going to look at the very simple galvanic cell, which is known as the zinc copper cell, namely the Daniell cell. Okay. So in the Daniell cell, we're going to have two compartments. Okay. Can you read this? This is 1 molar zinc sulfate solution, and then this is 1 molar copper sulfate solution. So we're going to have two compartments, okay? And then we're going to have two electrodes here. This is copper electrode, this is zinc electrode. You can tell from the color, right? This is copper. So copper electrodes will be immersed into the copper sulfate solution, and zinc electrodes will be immersed into the zinc sulfate solution. So what will happen is, once I connect this using my salt bridge, what will happen is zinc will lose 2 electrons. Zinc from the zinc electrodes will lose 2 electrons to form zinc 2 plus ions, and copper 2 plus from the copper sulfate solution will lose 2 electrons to form copper solid, okay? This is what we're going to see. In the way, we are going to generate 2 moles of electrons that will move from the anode compartment to the cathode compartment, or from the zinc compartment to the copper compartment, okay? So this will generate, if we're doing this correctly, this will generate up to 1.1 volts, okay? 1.1 volts. So let's begin now. To construct a Daniell cell, we will have, we will need 2 electrodes, zinc and copper electrodes, and 2 solutions, zinc sulfate and copper sulfate. Zinc electrode will be immersed into the zinc sulfate solution, and copper electrode will be immersed into the copper sulfate solution. These two will be connected using a wire to a voltmeter, okay? This is voltmeter. This is by which we measure the voltage of the electricity that we're going to generate here. Exactly. So this is basically a simple galvanic cell, which is known as the Daniell cell. Here I have my salt bridge. Okay, this is called salt bridge. So once I connect these two solutions using a salt bridge, we will start to see electricity being generated here. Okay, are you ready? Okay. So let's turn this on. So do you see that? As you can see, we have generated 1.05 volts of electricity using this cell. Okay, let's give it some more time. It will somehow increase. Now let's try to explain what is really going on here. Okay, so the basic thing here is the fact that copper 2 plus is more easy to get reduced than zinc 2 plus, okay? As you can remember from our previous discussions, there is electrochemical series, right? So copper 2 plus is found below zinc 2 plus in the electrochemical series, showing that copper 2 plus is easy to get what? To get reduced, okay, to get reduced, meaning zinc 2 plus ion is more likely to accept electrons than zinc 2 plus ions. So copper is very good oxidizing agents. I mean, copper 2 plus is very good oxidizing agents, and not zinc 2 plus. Zinc is very good reducing agent, okay? So my zinc in the zinc electrodes will lose 2 electrons, okay? This is our anode half reaction, which goes like this. So the zinc in the zinc electrode will lose 2 electrons to form zinc 2 plus ions, and then these 2 electrons will migrate all the way through the cables into this compartment, okay? Where are these 2 electrons now? These 2 electrons will be accepted here inside the zinc sulfate solution. As you can see, I have copper 2 plus ions and sulfur 2 minus sulfate ions, right? So these copper 2 plus ions from the zinc sulfate solution will accept the 2 electrons lost from the zinc electrodes and then will form copper solid. I mean copper solid. Is that clear? This is now my cathode half reaction, or the reduction. You guys remember CAR, right? Cathode reduction, and an anode oxidation. Good. So one thing here is when this reaction is going on, more of the zinc metal from the zinc plates will be dissolved into the solution, right? Forming zinc 2 plus ions. And then the electrons will migrate all the way to here, and then the copper 2 plus ions from the copper sulfate solution will get 2 electrons. Forming zinc solid, right? I mean forming copper solid. This means that more of these sulfate ions, the SO4 2 plus ions from the copper sulfates, will be accumulated here. Is that clear? Will be accumulated here. And then more of the zinc 2 plus ions will be dissolved into my solution. So as the time continues to go, more positive charge will be accumulated here and more negative charge will be accumulated here. So what do I have to do to, overcome this issue? This can be overcome using a salt bridge, okay? The salt bridge here is an electrolyte solution. Mainly, we can use copper chloride, copper nitrate. In this case, potassium chloride or potassium nitrate. In our case, we have used potassium chloride solution, okay? So inside our salt bridge, we have potassium ions and chloride ions, okay? These are the 2 ions that are present in the salt bridge. So I said earlier that more positive charge, more zinc 2 plus ions are accumulated in this part, right? So to neutralize this more positive charge, the chloride ions from the salt bridge will migrate all the way into this compartment, okay? And then more negative charges are accumulated here, negative charge from the sulfate ion. To neutralize this, the potassium ion will migrate towards this compartment, maintaining electrical neutrality of the cell. Is that clear? So basically, the salt bridge is here for 2 purposes. The first one is to maintain electrical neutrality by providing ions of positive and negative charge to both the compartments, okay? And then to make the circuit complete, so that electrons can pass. Is that clear? The circuit is complete. That's why we're reading a net volts here. So one question is, what do you think will happen to the mass of the zinc plates as the reaction continues? Speak up. Mass of the zinc plates would decrease, right? Why is this? Because it's getting dissolved into the solution. And then what do you think will happen to mass of the copper electrode. It will increase. Why? Because copper is being produced in our cathode reaction, right? In our cathode reaction. As you can see, the copper 2 plus ions from the copper sulfate solution are being converted into copper solid. This copper solid will be deposited into our copper electrode. Is that clear? Good. Uh, so one other question is, what do you think is the difference between electrolytic and galvanic cells? We have seen electrolytic cells before. Now we have seen simple galvanic cell. Can you guys tell me the difference? Speak up, please. Okay. Exactly. In galvanic cell, we're using chemical reaction to generate electricity. Okay. Another difference is spontaneity. Okay. Galvanic cells are spontaneous, meaning this will continue to generate electricity. This will continue to generate electricity until all the reactants are used up. Okay. How about electrolytic cells? Do the process continue when we cut the circuit or the source of power? No, that's why it's non-spontaneous, okay? This is spontaneous because the reaction continues, The reaction continues spontaneously till all the reactants and the ions in the salt bridge are completely used up. Okay, one another question is, can you guys tell me the net reaction here? The overall reaction? Here we have this is my anode reaction, the reaction that is taking place in this compartment. Zinc solid from the zinc electrodes is being dissolved into the solution by using 2 electrons. And then in the cathode compartments, copper 2 plus from the copper sulfate solution is gaining 2 electrons to become copper. So can you guys tell me the overall reaction here? The sum of these 2 reactions, basically. Exactly. So this is the overall reaction, okay? So we write the balanced half reactions first, and then we balance the number of electrons. As you can see, they are already balanced. We cancel the electrons out, and then the nets or the overall reaction would be zinc solid reacting with copper 2 plus ions, zinc solid reacting with copper 2 plus ions to form zinc 2 plus ions and copper solid. Is that clear? Excellent. Okay, one last question is, which one do you think is anode, which one do you think is cathode here, and why? We have 2 electrodes, right? Which one is anode, which one is cathode? Which one? Zinc is anode. Why? Because it is where oxidation is taking place. Okay? So, but here, the signs for the electrodes will be changed. Okay? Anode is negative electrode here, and cathode is positive electrode, unlike electrolytic cells. But one thing is always the same, which is oxidation takes place at the anode and reduction takes place at the cathode, okay? But the signs of the electrodes will change. It's anode is negative here. Why do you think is anode negative here? Why do you think is anode negative here? Because the electrons are being generated here, right? We assign negative charge to the ends where electrons are being generated. And then we assign positive to the end where electrons are being gained, right? So this is negative, this is positive. This is enough for our today's experiments. Thank you.